Okay, so we've moved on. It's one of the smaller stands in the show, MRO Europe in Barcelona, but I think one of the more fascinating in terms of what you do. We'll get into that in a minute. Erik De Zeeuw joins me. You are the, remind me, you're the
marketing manager
for aviation.
Yes.
For Materialise.
Yes.
Based in Belgium. Okay, so Materialise is a 3D printing firm.
Yes. So for over 33 years, we have been focusing on 3D printing.
So more than 3 decades?
Yes.
Although this seems new, it's not so new.
No,
okay.
Indeed. So, and yeah, we've been doing it ever since, and we're a global company of 2,400 employees.
Okay. So, yeah, a small stand, but a big company.
Yes.
Very quickly, for the layman, 3D printing, and I've seen it in action, and it looks like magic. I mean, but explain how it works and why it's so revolutionary.
Well, 3D printing is basically a technology where you additively going to create your object rather than subtractive or compared to machining or injecting compared to molding.
Right.
So it is a toolless production technology, so it doesn't require a manufacturing tool, which can take months to produce.
Yeah.
And from that point of view, it gives you design freedom to make designs that were maybe previously not possible, or it gives you supply chain advantages because you can produce something very fast without the need of the tool, so that you can address certain supply chain issues.
And locally as well.
Yes.
But we will get into those plus points. So you've got something here. Another word for it is additive, which means essentially you're taking the component material and kind of, I guess adding it and creating the part in a machine, which I've seen one of them. It looks like I don't know what it looks like, a large oven or something potentially. You obviously program it, and this part emerges from it. Over a period
So
of
typically,
time.
what you do, you have a 3D object which you are going to orientate. You're going to slice it up, and those slices you're going to feed to the machine, and the machine basically has a way to create the material. There exists hundreds of different 3D printing technologies, so depending on the material and the creation combination, it might be laser-based, it might be extrusion, there's a whole range of possibilities, but then you're going to create your layers one after the other, and that way build up your object.
And the source material for this, it can be all sorts of things. I mean, this is I guess this is a piece of plastic, it's metal. I mean, they're now starting to 3D print body parts, so it can be, I guess, organic material.
Bioresorbables.
So there's really no limit. It's what is required for the usage. What you put in, you get out, and you can put pretty much any materials in, can you?
There is some limitation because you need to be able to 3D print it, so it's related to the possible processes that can be applied. So not every material can be printed, but the market is growing double-digit every year, and so new technologies and materials are popping up in every market. So ceramics, silicons, metals, polymers.
So there's clear application for this in aviation. That's why you're here, and that's why you've got an aviation department. But you operate in other sectors as well as aviation. So which other sectors is this growing in as a concept?
So Materialise has become big on 3 pillars. Basically on manufacturing services of printing parts for other companies, on software for the 3D printing ecosystem, and on medical applications, patient-specific applications with 3D printing, like implants. For this. These 3 business units are almost equal in size. Of the manufacturing service unit, we produce on one end prototypes, like new developments that will be manufactured in another technology, but more and more we're producing end-use parts. Those end-use parts we produce for various segments, like eyewear or footwear, but also for aerospace. And so a substantial part of Materialise is now focusing 100% on aerospace. We have a production organization approval, and we can make flying parts with additive.
Okay, so another advantage is, and you maybe talk me through this, what the part you've got in your hand now, is that what you're able to do with 3D printing is take a component, say, of part of a seat or something, which is quite complicated with many parts, and print a single part in plastic, so it's A, lighter, B, it reduces the number of parts, which reduces the complexity and maybe certification required. So that's one of the advantages of 3D printing.
So the advantages you can cut up basically in 2 sections. You have the product drivers and you have the supply chain drivers. So product drivers could be functional integration, combining different parts. It could be lightweight reduction, so you topology optimize your part. You take away
lightweight plastic.
Or you take away material where you don't really need the strength, and so make a very complex shape that has the same strength than basically a block. So that are drivers as well, but then you have the supply chain drivers. Easy sourcing, low quantities. You can cheaply produce low quantities and source them. So those kind of things.
Yeah. So again, the supply chain thing is really interesting because we've had a number of conversations already this week at the show about the supply chain issues. Availability of parts. So a lot of parts are obviously being recycled in the aftermarket. We've got OEMs creating new parts, but this is a way of creating those parts very quickly in small batches overnight and locally to where they're needed as well, because the machinery they needed to do this is not so it's not a huge factory, for instance. So you can order the exact number of parts you need, have them delivered the next day, and you're done. You don't have to then warehouse a bunch of parts as well. So there's a lot of other factors that are really at play here, aren't there, for the supply chain?
Yes. I want to mitigate maybe the advantages on decentralization. This is true for certain segments in additive. If you're prototyping, it's decentralized, it's produced. If you talk tooling, every production facility, or like where they have process engineers, they have their own 3D printing and they can do it overnight and so on. If you're talking more highly regulated industries, you have specific machines with maybe specific post-processing and specific quality management systems, which are not so easy to decentralize.
Okay. So there's still inevitably, but because aviation, there's a centralized aspect to it because of the nature of aviation and the regulation. And I know on the wall to the right here, it talks about being certified. So what areas are you certified as a business?
So with respect to aerospace, we are a EASA Part 21G production organization, and we also are an approved Airbus supplier. And also an EN 9100 approved.
So give us some idea on figures, numbers. How many parts are you putting out there at any given
Every A350 now carries at least 100 parts from us, and we have been doing that for over 10 years. So in that period we have produced over 150,000 for Airbus alone. But we do work for the whole value chain of aerospace, tiers, component suppliers and those kind of things, and we have produced over 500,000 flying parts.
Before we have a quick look in more depth at some of the pieces you've got around us, I know you've got some news coming up around certification. I know you can't probably let it it's being embargoed as we speak today. But what can we expect? What's the announcement?
So all of the flying parts that we've been producing up to now have been polymer. So in two types of plastics, but we have been producing metal parts for the industrial range quite a few years, and we're now taking the step to do that also in metal.
Fine. So it's about getting metal certified to fly. We'll see a bit of that now, I think. Just talk us through what you've got in your hand there. So what is that?
Well, this is one example of a flying component that we have made for Airbus. This is a cabin spacer. So you have your range of cabins, and then you have a bit of room left, and you fill it up. So it is an example of the technology that we can do for Airbus. So it's the ultimate 3D printing technology. It's filament fiber. It's basically if you ask people what is 3D printing, that's what they know. It's like extrusion of a wire that you place and then build up your model. So it showcases our capabilities for interior finishing.
And traditionally, would that be a single part like this, or have you combined numbers of parts into the one component now?
I wasn't involved on the design, but what Airbus definitely did is they redesigned it to optimize it and save basically 20% of weight on this component.
Can I have a feel? Because obviously it's light. It feels light. I don't know what the original would have been like, but it's very, very strong. You can feel that's not going to be broken anytime soon. It's very robust. Let's talk us through this other part here. This has got Pegasus Airlines stamped on it, so it's clearly off a Pegasus aircraft. Go on. What is that?
So this is the cover of an emergency handle. Pegasus approached a DO partner of us, Sterling Dynamics, and basically they wanted to get rid of the polycarbonate cover that comes with the original aircraft. And they wanted something more beautiful and something more that doesn't really require drilling of the aircraft fuselage.
To attach.
Attach. So this is a non-drilling solution, so you don't make holes in the fuselage, which is a benefit.
Yeah.
And it's also customized and so on. So,
to them. Okay. Yeah. And that will go on to over a door. If I fly on a Pegasus, some Pegasus, I'll see this on a door.
You should be able to see this.
It'll be one of yours. Yeah. Okay. Yeah. Right. The third one is a bit heavier, isn't it?
Yes.
But this is the metal.
Yes. Well, this is
component.
This is to inspire what metal printing can do. This is an actual piece that we built for a research group that built a small-scale rocket engine. So this is in Inconel, so it showcases the granularity and the fine resolution of metal powder printing, which we do. So it has cooling channels and so on. So it shows the complexity that you can achieve with 3D printing.
It's actually quite beautiful in some ways, isn't it? And it's heavy. You know, so
it's a real steel.
It's a proper piece of metal, isn't it? It's incredible. Okay, so this is the kind of thing that now you'll be producing more of once you get the certification.
Well, certainly we will start with lower criticality parts. So because there's still some certification efforts required for the higher criticality parts. But this kind of products, which is more related to the space segment, is actually already standard practice in the whole space industry.
Okay, good. Look, final question before we finish, because we're nearly out of time. But just where is this going? I mean, are we going to see 3D printing become? It's already obviously adopted quite broadly, but are we going to see it really take off, particularly with the supply chain issues that we're currently facing, because it's an answer to that?
Well, for us, it's growing very significantly. We feel that we've been doing flying parts now for 10 years, and it's really established, and we see it growing massively. And then what we see from the industry is that we will step by step take it up to more critical parts, and it will become more mainstream. Definitely.
Yeah. Okay. Well, we'll certainly keep an eye on what comes along, and good luck with your new announcement. And thanks very much for joining us on ABNcast.
Thank you, Lee, for your time. All right.